Hi everyone, welcome back. Today we are diving into another data fabric lab. In this lab, we are focused on work with data in event houses in Microsoft Fabric, and more specifically, the query language that makes them so powerful, known as KQL, Kusto Query Languages. KQL is specifically designed for time series data and event streams. And once you see it in action, you will understand why it's so effective for real-time scenarios. So first, what exactly is an event house? Think of it as a specialized container designed specifically for storing and analyzing event data. Inside an event house, you have KQL databases, and within those databases, you have tables that store your like time-stamped events. So what actually make this? So they are optimized for append-only scenarios where data is constantly streaming in. You are not updating existing records or deleting data frequently, but you are continuously adding new events, and you need to query them fast based on time ranges. Think like taxi ride is an example. Imagine events capturing every ride, pickup time, drop-off time, number of passengers, fare amounts. So all these events are happening continuously across a city or somewhere, and an event house is designed to ingest this flood of data efficiently and make it immediately queryable. The key advantage here is that event houses are built for scale. While talking about handling millions of events, and query performance stays fast because the underlying engine understand that you are almost always filtering by time and aggregating like across dimensions. Now, the concept here is pipping. So what actually it does? So it has got, if you look here, like it has got two fundamental operations. Now, before that, let me talk about something. Like let's talk about basic. Um, KQL itself uses a concept called pipping. Now, you have worked if you worked in the Linux environment or PowerShell, that you know that there's a pipe options is available. So, if you let's say that bike stream in our example, you use the pipe simple and then is the take 100. So that means it will check that bike stream table and give the 100 records. Now, if you check that it's getting more powerful because you can chain multiple operations together. Look here with the project. So with project, you can select specific columns like here, the street and number of bikes that we are selecting. And this that forward backslash, that is mainly for comment. Now let's talk about two other operations, KQL operations. One is project and then where. We'll also talk about summarize and sort by. So project is how actually you select where columns you want to see. Then where clause is to filtering, like how we can narrow down which rows we want to um, like get the values for. Like here we have in where neighborhood equal to Chelsea. So that means only it will show me the data for Chelsea neighborhood. Then you can see that there is an option for like empty doc equals to number of empty docs. So this is like an alias. So we can rename columns um, to see like what kind of column name. If there is a bit complex name you want, you can just use an alias to get the column name. Then like think of summarizing data. So in that case you can use aggregate function. There is other options like sum, count, average, mean, max. So in this case we have used summarize. Total number of like bikes by neighborhood. You can do that. Other option that you can sorting data by using sort operation. Here sort by, we can use that one. Other than that, what can happen like in real world that when you are using this database, sometimes fields can are empty or not. So KQL has functions like is empty a and is null to detect this. Is this with the case function to handle this situation. Other thing that the KQL is native language for Eventhouse and Fabric, but we can also use T-SQL support. Like we can use the similar commands with the Transact SQL. We'll switch to our lab. But the T-SQL endpoints lets you query KSQL database using familiar SQL syntax. But when we'll use then this instead of TSQL, we'll use KQL. So if we are doing quick analysis or building reports in familiar tools, TSQL is fine. But for complex time series analysis, real-time monitoring, or anything performance critical, KQL is going to serve us better. It's optimized for the underlying data structure in that T-SQL cannot match. So let's do start lab now. So in this layer, we'll go through work with the data in a Microsoft Fabric event house. So an event house is used to store real-time data related to events, only captured from streaming data source by an event streams. So within an event house, the data is stored is one or more KQL database, each of which contains tables and other objects that we can query by using uh, KQL or Kusto Query Language or a subset of structured query language, SQL. So in this lab, we will create and populate an event house with some sample data related to taxi rides, and then the query the data using KQL and SQL. So let's start the lab. So for this lab, work with data in a Microsoft Fabric event house. The very first thing we need to create a workspace. So for that, here I have already connected to Fabric console. Now here click on workspace and create a new workspace. Give a name, workspace name, and under advanced you see the different license mode, but make sure that Fabric capacity is enabled and click on apply. So here you can see that a new workspace like which is empty. Now we're going to create an event house. So for that, on left side you see that workload, click on workload, then select the option real-time intelligence. Now from here, click on the Explore Real-Time Intelligence sample. So it's creating a few objects if you see here. So it has already been created a event house. If you look here, that is RTI sample. So now it's doing sample data collection. Now it's creating sample. So it's showing Power BI report created. Close that one. Option is explore. So click that one. Close all the buttons. Now, if you look here, this panel on left, you will see that Event House contains the KQL database with the same name as of the Event House. And also see that there is a bike stream table has been created. Now let's query data by using KQL, which is actually Kusto Query Language. So on the left, you see that sample query set. Click that one. So we can just modify your table here. So our table is bike stream. We can just copy there. Otherwise, also we can open a new tab like this, and we can execute the query. So this pipeline character that you see here is used to um, for purposes to separate query operation in a tabular expression uh, statement. And this is also used as a logical OR operator. So what it actually we see that it is returning 100 rows from that table. Now let's execute another query. So here you see that you can use project and take to view a simple number of records into the table to check the data. So let's execute this one. And this you see that that to backslash forward slash. So you see that one actually for comments. So it's considered as a comment. Then it's just giving the from that table. It's giving us like 10 values for project street and number of bikes columns value. And now we are going to execute next query. Here we are going to this is known as like renaming columns in our case. So here is the number of empty docs, and we'd like to see as a number of empty docs. So let's execute that query, and you can see that number of empty docs is coming this one. Now next we are going to do a summarize function or summarize keyword. So here to see the total number of bikes, so execute that one. You can see that how many bikes are there. Now we're going to use group by function. So group by, just to see that how many bikes are available for each neighborhood. So here you can see that for this neighborhood, like my n neighborhood, there are 3,355. If any of the bike points has a null or empty entry for neighborhood, the results of summarize will include a blank value. So for that, like just to make sure is there any empty or none value, therefore we are going to modify this query so that is empty and is null. So for with the sample data, maybe it's not here and we don't see, but in real data there can be possibly. So now we'll go through some more operation. So the very first thing we're going to do that is sort data. So we are sorting data by neighborhood ascending. So neighborhood. Mm, But if we descending, you can see that format. And now we are going to use order by clause. So order by neighborhood. So order by and sort is almost like they are the same. So now we are going to use more with filtering data. So filtering is like the where clause, we can put some additional condition. So let's see some SQL on that. Not SQL, that is KQL. So here you see that this is coming for a specific neighborhood, that where clause. So therefore we can see here for Chelsea 6,000 bikes. Now let's do some like the similar operation. We have been used like KQL. Now we're going to use transact SQL. So you can open another tab here. So you can see the top 100 from that bike streams. Then next, to get the specific columns, then we have check the alias, like rename the column. So if you look that, we are just doing that similar way, but this time we are going to use transact SQL. That one, rename that column name. Now going to do all the summarize operation. So you can see the total number of bikes. Now we are going to do that total number of bikes based on uh, neighbors or neighborhood. I have done some here. Next, we are going to do a case statement. Group bike points were an unknown origin into an undefined category so that we can follow that up. So that was the select case. Mm, and, and when we are saying that it is not, so that not defined. So when there is an unknown origin into an undefined category, so that we can follow that up. Now we are going to use sort operation. And after that, we're going to do a filtering data. Having neighborhood is Chelsea. So here we have done those SQLs in like exploring the KQL database. That's it for this lab. See you in next lab.